PreAP QCA 3 retest review. Just a quick reminder that the problems you see on this retest review are going to be extremely similar to the problems on the actual retest, so make sure that you can answer these questions independently before you take your retests. I am going to go pretty quickly through this video, so if you think I'm going too fast, remember, it's a video, pause it. All right, looking at the first one, solve the inequality. All right, we're going to treat it like an equation, right, and we're going to solve this thing. We're going to subtract 3x from both sides. That's how I personally like to start these. And I've got negative 1x now plus 7.5 is greater than 4.7. Next, we got to get rid of the 7.5, so I'm going to subtract that from both sides. And I get negative 1x, and you can see I did the math over here in my calculator already, is greater than negative 2.8. Well, we cannot leave this negative here, so we're going to divide it out, which means that now I've got x and I've got positive 2.8. And because I divided both sides by a negative, I have to flip my inequality around, right? That only happens when you multiply or divide both sides of an equation, an inequality, by a negative number. All right, problem 2. All right, we're talking about Girl Scouts. They are selling chocolate chip cookies for $12 for the first dozen and 50 cents for each additional cookie. They're also selling peanut butter cookies for $13 for the first dozen and 75 cents for each additional peanut butter cookie. All right, just a quick note, dozen means 12 cookies, just in case you didn't know. And let's go ahead and let's write two equations to represent the cost. So I'm going to say C for cost. So I'm going to say C equals, and let's just do the chocolate chip cookies here first. So we know they're going to cost us 12 bucks if we order a dozen. If we order more than a dozen, so plus, they're 50 cents each. So I'm going to put 0.50, but I can't just say times X. Or let's use K for cookie. That doesn't work because then every single cookie is 50 cents plus the original $12. So the way that we make this work is we got to use parentheses here. And we have to say, okay, the number of cookies they buy, except they already paid for 12. So I'm going to say minus 12. So this essentially means that they're only going to start getting the 50 cents added on there once they buy 12 cookies or more. Sorry, more than 12 cookies. All right, so you got to have that K minus 12. Now that you've seen this example, the next example is very similar. This says the first dozen costs $13, and each additional cookie is 75 cents. Now remember, we're doing K minus 12 because the first dozen, the first 12 cookies are already paid for. All right, so we still keep the 12 right here. All right, problem number 3. Write the quadratic equation that goes with the graph. You guys don't make this hard on yourselves. Get yourselves 3 points. All right, 3 good points. Make a little table and put it in your calculator. This point was negative 2, negative 1, then I got 0, 0, and then I got 2, negative 1. I'm going to go to Stat Edit in my calculator, and I'm going to type in those 3 numbers. Now you do need 3 numbers, okay? You got to have the vertex and a point on each side of the vertex. So it looks like I got negative 2, and then I'm going to do 0, and then I'm going to do positive 2 for my x's. All right, for my L2s, I've got a negative 1, and I've got a 0, and I've got a positive 1. That didn't work, so let's retype. There we go. And then I've got a positive 1. All right, go to Stat Calc, and now make sure you choose option 5 for quadratic regression, because this is a quadratic graph, right, the U shape, the parabola. And we've got our equation that didn't work for some reason, which means I typed something in wrong. Let's check it. All right, did I type in negative 2 and 0 and 2? Yeah, all right, but I missed the negative over here. Do you see that? This one needs to be a negative 1. All right, let's try again. Stat, Calc, option 5. And we do get an equation this time, hopefully. Yes, we do. Okay, so we've got just y equals negative 0.25x squared plus 0x plus 0. Now, hopefully y'all know if they just have zeros on the end there, I don't need to write them. And so this is my equation. All right, example 4. What is the x-coordinate of the solution of the systems? Well, since we have y equals and then not y equals, right, our setups are not the same. This is when we use substitution. So I'm going to take this 2x plus 3, and I'm not going to write y, equal to 25. So basically, I just didn't write this y. The reason is because I know what y is. Y is x plus 5, right? So I'm going to put this in for y. And if I put it in right here, now this is a fairly simple problem to solve. Just distribute this 3 and I get 3x plus 15 is equal to 25. Now I'm going to combine my like terms and get 5x plus 15 is equal to 25. We're going to subtract 15 from both sides next, which means I've got 5x is equal to 10. And last but not least, we're going to divide both sides by 5, and I've got x is equal to 2. Now remember, this problem only asks you for the x coordinate. Usually you have to do x and y, but not if it says just x, so we're done. All right, problem 5. What is the solution to the following system of equations? And see here we do have an ordered pair. So we're going to have to find x and we got to find y. All right, well this one is set up for elimination, right? Because my x's line up, y's line up, equal signs, everything lines up. So this is going to be elimination, which means something should eliminate. As of right now, we have a 2 and a 5, not going to eliminate, and a negative 2 and a 3, not going to eliminate. So we got to fix that. I get to choose which one I want to make match. I'm going to go ahead and I'm going to make the y's match. I'm going to turn both of these into a 6 and a negative 6. So what that means is we have to choose what to multiply by. So I'm going to multiply this one by 3. So my new equation is going to be 6x minus 6y is equal to negative 18, right? You got to multiply the 3 times everything in there. Now remember, I want a positive 6y right here on the bottom, so this equation is going to be multiplied by 2. This is going to give me 10x with a positive 6y is equal to 2. Now my y's eliminate, which is awesome, and I get 16x is equal to negative 16. Divide out the 16, and I've got x is equal to negative 1. So I am doing pretty well, right? X is negative 1. Find y, simply plug in this x value into one of your equations. It doesn't matter which one. I'm just going to do the first one. So I've got 2x minus 2y is equal to negative 6. But x is negative 1, so we've got to use a negative 1 right there. All right, so really I've got negative 2 minus 2y is equal to negative 6. To solve for y, now I need to add 2 to both sides, which means I've got negative 2y is equal to negative 4. Divide out the negative 2, and I've got y is equal to positive 2. So my solution is negative 1, positive 2. That's the point where the two lines will intersect. That's my solution. All right, graph the inequality, problem 6. Before I graph, I definitely want to get y by itself. That's how I like to do these problems. I feel like that's just much easier. So I'm going to first move the 3x to the other side, right? Imagine it's like just subtracting 3x from both sides. So now I've got negative 4y is greater than or equal to negative 12 minus 3x. To finish it off, we're going to divide both sides by negative 4. And since we did divide by a negative, we have to remember that our inequality switches directions. So now it's a less than sign. And on the right side, I have a positive 3 and a positive 3 over 4x. Okay, so let's graph this thing. My intercept is the number without x, so that's 3. My y-intercept. Now my slope is 3/4, so I'm going to go up 3 and over 4 to find my next point. You get as many points as you want in either direction, all right, but you need at least 2 points. I think I went over 5. Up 3 over 4. And go ahead and graph your line. Now, I made mine a solid line. The reason it's solid, right, we look at the inequality. This is going to have a solid line because it has the or equal to symbol. And it's going to be shaded below because that's a less than sign. So it's going to be a solid line that we shade below. And that's my graph. All right, write an expression in radical form that is equivalent to 5x to the 1/4. Well, let's remember we have a rule for this. It's on our formula card. It says a to the m over n is equal to n as the index number, a to the power of m. So we're going to rewrite this. This is on your formula card, guys. You don't have to memorize this. So first, let's separate 5 times x to the 1/4, right? Because this is the only expression that needs fixing. Sorry about the bell. So we're going to say 5 times, and then we're going to switch this. Okay, the bottom number, right? The bottom number goes as the index. So we're going to say 4 in that little spot right there. And then x gets this as an exponent, which really don't need to write. So let's clean this up. So this looks like 5, 4 is the index, and then x inside the radical. All right, that is my completed expression. Problem 8, what is the range of the function f of x equals 1/2 x plus 2? And the domain is, and then it gives you the domain. Make a quick table because we know that domain means x values. So these are x values. And we got -2 and 2. We just need to find those y values. All right, and I'm going to use my calculator for this to save time. So f of x is the same as y equals. I'm going to go ahead and I'm going to put this equation into y equals. And I'm just going to do 0.5 for 1/2, right? 1/2 x plus 2. Now I'm going to go to my table in my calculator. And I'm looking for -2 and 2, right? So -2 gives me +1 for y. And +2 gives me 3 for y. So my range, I'm going to write it real similarly to the problem, except I use a y, goes from 1 to 3, right? Those are the y values that go with the x values I was given. Problem 9, what are the zeros for the graph shown below? Zeros just mean, and by the way, this should be a closed circle. Sorry about that. So the zeros are where we touch the x-axis. So we have x equals 0 and x equals 4. Just as easy as that. If you get a graph, it's literally where does the graph touch the x-axis. Problem 10, describe the effect on the graph of f of x equals x squared, and then it's transformed to get g of x, which is 1/3 x squared. So let's go ahead and let's look at the graph of x squared. All right, I'm going to do that here. X squared. Here's my graph. It is right here in the middle. All right, 1/3 x squared. Why don't we just do it in a different color on the same graph, just like my calculator does. Yours doesn't do this, so sorry. All right, so we're going to go back to y equals, and we're going to type in, I'm just going to do a fraction like this, 1/3 x squared. And let's graph it with the original. So there was my original in blue. My new one is getting wider. So all you need to say for this is the graph of g of x is wider. Okay, and that's your answer. Those are all 10 problems on your retest review for QCA 3. Again, make sure that you can do all these problems independently before you take your retests.